lag 0, lag 1, lag 2, up until what lag again?
12.
Fantastic. Okay, so if you did it, can
Can I
some
share?
can
Can I
you
share my screen?
can you share your screen? If you maybe send it to me,
Okay.
let's see. Yes, if you send it to me, then can you send it on? Put it on chat. Let's see if we can get it.
Can I send it on the chat?
If you can't,
There's
How
a
do I do it?
file button.
There's a file button. Okay. Oh yeah, there is. Okay. Um,
if not, you can just send it to me by email and I'll upload it.
I just sent it in the chat. Just let me know if it works or if it.
Okay.
I don't know. Listen, I don't know if I did the right thing. I literally like.
Who cares, Joseph? At least you did it.
I know there's like some kids in this class that are like a lot more advanced and they probably know.
Yeah, they're like geniuses, right? Don't worry. Don't worry. I'm not a
Like-
genius. Danny is a genius. I am not a genius. Don't worry about it. Did everybody get it?
It was like my first time doing something like that, so I don't know.
Don't apologize. Joseph, at least you did it. I didn't do it. So, and some other people didn't do it because I couldn't be bothered to do up to like 12. I was so busy. Why can't I? I think it needs me to save it on. Did anybody else get it?
Yeah, it opened up fine for me.
Okay, I'm trying to open mine up now. Oh, I'm in the wrong. Okay, you know what? Let me just save it here. Yes.
Joseph, can I ask you a question about your Excel worksheet?
Yeah, go
So
ahead.
in column letter L, why do you have the data only until 2005? I didn't do it. I'm just wondering.
In L, I don't know what you. It's till
I
2000.
think that's like the whole part of how we're like changing by the lag. You know what I mean? Like,
Oh, you mean in M? In column M.
Yeah, to
Yeah.
get the data in.
Yeah, why it's only up to 2000? Because that's like the point. Like each one, I think. I don't. It's my first time doing this, so I don't know really. But I think each time you're supposed to subtract, like take one off the top.
Okay.
Every
Thank
time
you.
you added a lag, like 1 + 2.
Got it.
Am I right for other for those of you?
that's what I did. I'm not sure if that's correct.
Okay. How's the okay? So I did 2 graphs, like on the bottom. I don't know if anyone's looking. I did one including the correlation, and then one without the correlation one, because that's like.
All right, so I'm just opening up your document now, Joseph. What happened was, I think your document has exactly the same name as my document. So I tried opening it up. What is this? So this is the correlation. So did you send me 3 graphs?
I sent you the whole Excel sheet, and then there's on the bottom, if you scroll down, I did.
Okay.
So I did the autocorrelation function. I did one including without, like not including one, and then one including one.
Okay.
And the autocovariance is just there was no like.
All right. Let's see.
Professor, will you be able to share the screen?
That's what I'm trying to do right now. Okay, here you go. How do I make this thing bigger? I make the font bigger, right?
You can zoom in the corner, all the way down in the right-hand corner, all the way
this
down.
one. All the way down here. And then I can, here, right? I can increase it.
Yeah, right there.
All right, thank you. All right. Okay, so on the So Joseph, thank you so much. So on the bottom here is on the x-axis is lag, and on the y-axis is autocorrelation. Okay, now just one quick comment, okay, everybody? Just one quick comment. Again, it is my fault, okay? Let's see. So the first one does not include lag. Okay, the second one includes, this second one includes lag 0. Awesome, okay.
Yeah.
Okay, so everybody, I'm focusing on this graph right now, okay? As you can see that. I'm not interested for now whether, it says, could somebody resend the file again? All right, you guys take care of that. I'm not interested now whether Joseph is correct or wrong, okay? That's not my interest. But what I'm trying to do now is I'm trying to just take a look at this. And so if you notice, every time, again, somebody answer me this question. Anytime you do autocovariance or an autocorrelation. So now let me talk about autocorrelation. Anytime you calculate autocorrelation at like 0, what must be the number be every time?
1.
1, okay. You know what? Let me begin to record, okay? I wasn't recording, so I'm going to.
This meeting is being recorded.
Okay. So hello, everybody. I want to thank Joseph Baghdadi, right? Yes, Baghdadi.
Yeah.
Thank you so much for sending me your spreadsheet. So this essentially is Joseph's result. So again, if Joseph, you calculated all the numbers correct, then this graph is correct. So that's good, okay?
Really? That's the right way to do it?
Yes, that's the right way to do it, okay.
Awesome, thank you.
Okay, so let us assume that this is correct. All the numbers are correct, negative, negative, positive, and so on and so forth. Now, somebody answer me this question. Anytime you calculate autocovariance at like 0, and now please listen. Anytime you calculate autocovariance, not correlation, autocovariance at like 0, lag equal to 0, what exactly are we calculating?
The variance.
We're calculating the variance. Fantastic. So autocovariance at like 0 is the variance. What happens when you calculate autocorrelation at like 0? What must the number be always?
1.
Which one? -1 or +1?
Positive 1.
Positive 1. Everybody be careful. Whenever you are talking about correlation, you have to specify the number and the sign. Remember? Yes? Okay.
Yes, sir.
All right. So from now on, anytime you want to, you look at a graph, and the graph is an autocorrelation function. We call it ACF. It typically begins at lag 0. So lag 0 is, between, wait, is this lag 1 or lag 0?
I think it did it as lag. It's lag 0, but I think it considered it as 1.
As 1, okay.
Yeah.
So let's.
But it's lag 0 because you see how 12 it's really 13.
Yes, it should be lag 0, okay?
Yeah.
So this graph actually should be moved to the left. It should be indented to the left, okay? That's okay, Joe, thank you. It should be indented to the left. So anytime you look at an ACF, autocorrelation function, this point here should be on the y-axis right there, okay?
Mm-hmm.
And then other lags at lag 1, this should be lag 1, this should be lag 2, lag 3, lag 4, and so on and so on. So the function would be, you can draw it this way depending on what the numbers you obtained are. Okay, everyone? Okay, so an autocorrelation function is simply a graph like this, or a table. Joseph, before you plotted this graph, maybe you created a table that has lag 0, 1, 2, 3, 4, up to lag 12, and then the autocorrelations.
If you scroll to the left, you'll see it.
Oh, okay. Let me go to the left. Go to the left of this side here.
Like if you click on the bottom, no, like on the like the arrow on the bottom right, no more to the right, all the way to the
Here?
right.
Oh, here.
Yeah. So if you click like to the left, the other one.
Okay, so let me click to the other one. The other one, sorry. All right. Forgive me, I'm a professor. Exactly.
Yes, I did that.
Okay, so this is at lag 0. So S here is 0, S is 1. The lags are, so this is lag 0, lag 1, lag 2, lag 3, lag 4. And then these are the autocorrelations. Essentially the correlation between xt and xt plus 0, xt and xt plus 1, and so on and so forth. And then you told Excel to plot it here, yes?
Yeah.
Okay, fantastic. So you can, so this table here, this one, this table is an autocorrelation function because we are putting up the relationship in a table. But typically when we talk about autocorrelation function, where everyone is thinking about a graph, you plot the content of this table on the graph. Okay, everybody? This is, I mean, you guys are going to be tired of me telling you about ACF or asking you to do ACF. It's easy. It's just one command in R, but we haven't gotten there yet. Later in chapter 2, we shall be doing the R command, and you'll see the command you will use using the appropriate package, okay? But not now. All right. Thank you, Joseph. All right.
Sure.
I have a question.
Yes, ma'am. Who, Lily?
No, it's Roxalana.
Yeah, Roxalana, go ahead.
So what's the second graph autocorrelation function? I think Joseph tried to do it for covariance. Is that right?
Which
No,
one? This
the one on the bottom.
The one left.
I just did the one left on the side by side. I just did both of them. One includes lag 0 and one doesn't.
Oh,
So
Okay.
one is not including lag 0 and the one on the right is including lag 0.
Okay.
I just didn't know which one the professor wanted, so I just did.
Oh, okay. So
Yes.
can you scroll down for a bit? Because I think, did you also make a chart for
For
covariance?
auto, yes.
Yeah.
So this one is called the autocovariance function. But as you will see, because just like you studied in statistics and in econometrics and in finance, finance 3000 or finance 3710, when you calculate covariance can be any number, very large, very small, with different units, plus or minus, right? So that's why we do correlations, because by moving away from covariance into correlation, then we can normalize covariance and restrict the value to go between -1 and +1, and that's what we call correlation. So it's easier for us to deal with correlation because the numbers have to be anywhere from -1 through 0 to +1. So we can handle that, yeah? It's easy to visualize and to think about. So we don't typically talk about covariance, but you have to calculate covariance in order to get to correlation. Okay, Roxalana?
Yeah, so I just had a question about his numbers because I have different numbers. Maybe I just did it wrong.
Okay, let's not talk about the numbers for now, okay? But I'll talk about the numbers later. We shall.
Yeah, I just wanted to know, where do you find covariance? Because in my chart, I guess maybe I looked at the wrong number and I plotted the wrong covariance. Is it possible for you to show me, like, you know, that chart that we made for covariance? If you scroll up.
Okay, so let me scroll up.
Yeah, like these charts over here.
Okay.
Which one would be covariance? Because I use like -4.84.
So the covariance will be on the first table. So here.
Yeah, I wrote the labels right there. If you go.
So this is everything here will be covariance. Remember, that's how I did it in class.
Okay, and for correlation, the number would be on the bottom.
At the bottom, yes. Okay.
Okay, thank you.
Right. Yes. Yeah, keep the questions coming. I love having questions. Okay. Thank you, Joseph. Okay, thank you so much. So I'm going to minimize this now. I'm going to stop sharing this. Then I'm going to bring up my own Excel spreadsheet because we are not done yet with the definitions. Okay, but can you tell me, was this fun or not? I mean, who wants to do who wants to do anything else but calculate autocorrelation ACFs? And I mean, this is fantastic. I know it's a lot of work, of course. But if you're like Sophia, if you're like Joseph Baghdadi, if you're like Danny, if you're like Roxolana, all of you are having fun doing this. Even though sometimes you feel like pulling, if you have hair, you feel like pulling out your hair. But at the end, believe me, we're going to learn many things in this class, okay? So everybody just be patient with me, okay? All right? Okay. Now, I want to continue because we're not done yet. Okay, good. All right, so I'm going to stop sharing this. Thank you, Joseph. And then I'm going to bring up my own, let me see if I can find my own chart. I always have to be careful with what I'm doing here. Let's see, let's go up, let's go up, let's go up. My other laptop is messing me up. Okay, good. So this is my, I'm bringing up my own, I'm going to bring up my own thing here. So let me show all windows. All right. Okay. My screen is, you cannot see my thing. So let me go back. Sorry, I'm not talking to myself. All right. Can you see this one now? With this, I have on row 14, I have it in red. Can everybody see it?
Yeah, I see it.
Yeah.
Okay, good. All right. Hey, where's my man, Danny? Where are you, Danny? And Danny, can you remind everybody, all of us, what is the definition for a weak stationary process? What are the three conditions for a weak stationary process? I said it last class. The first one is the mean has to be what?
Constant.
The mean has to be constant. Awesome. How about the variance?
Constant.
The variance has to be constant. Okay.
The first two moments has to be constant, right?
The first two moments must be constant. The mean, constant. Variance, constant. Okay. What else? What's the third condition?
Covariance constant.
The autocovariance. Please, in this class, get used to calling it autocovariance because it's only, we're dealing with only one series. Okay. It is the
Okay.
covariance and correlation within itself. Thank you. But I understand what you mean. Now, okay, what about the autocorrelation? What did you say? The autocorrelation between successive observations must be constant, yes?
Yeah.
Yes? Okay, good. Excellent. And then between Tuesday and Thursday, all of you, or most of you, at least you attempted to, some of you successfully, some of you not quite, you're still working on it. We did, if you're looking at my spreadsheet, we did correlation between xt and xt at lag 0, xt and xt at lag 1, xt and xt at lag 2, and so on up to lag 12, okay? Good. So now, I know you all did this, but can everybody go here at the bottom with me and tell me, so this first one, this first series of tables are the autocorrelations. Suppose we did all of this correctly. Can anybody tell me what is the autocovariance between xt and xt plus 1? Tell me the number.
-4. -4.84. -4.85.
So between xt and xt minus 1 is this number, correct?
Yes.
Okay. And what is the autocovariance between xt and the second lag?
-78.72.
Fantastic. And then you did it up to lag 12. Yes, everybody? Nadia, you did, right?
Yes.
Yeah.
Awesome. All right. Okay. Now, can anybody explain to me what exactly do I mean by correlation between xt and xt plus 1, lag 1? Can you explain it to me in English?
Professor, I think it's the covariance between. You're asking for autocovariance?
Yes, autocovariance. And try and explain it without using the word autocovariance.
Okay. Okay, somebody else.
Okay, it's okay.
Well, I think that means that
Who is
you
talking?
have
Who is talking?
Alec.
Alec. Okay, hi, buddy.
Yeah, you have values that repeat themselves. So, and if the number is the same, then you have the same, that word that I'm not allowed to say, the same variance. And then if it's not, then if the numbers do not repeat themselves, then you don't have the same variance. And if you have a negative variance, covariance, I mean,
Okay, look,
covariance is the variance of the first, the variance of the second times correlation, right?
okay, look, I know exactly where you're going, but I need to explain this in a simpler way. Look at this. Look at these two columns here, xt and xt plus 1, right? All these numbers, what's the relationship between all these numbers? This 11.62 is just one time period away from this 37.49. Is that correct?
Yeah.
Yes.
And then this 37.49 is just one period removed from 43.61. Is that correct?
Yeah.
Okay. How about on this column? This 11.62, just like the first one. And what is the relationship with 43.62? 11.62 is exactly only 2 time periods removed from 43.61. Are you with me so far?
Mm-hmm.
Okay. The third part of that definition says, anywhere you begin. Here, we began with 1937, okay? 1937. And then I'm going down. All the numbers, one period away. That autocorrelation function shows the relationship. Because this number says, this autocovariance number says, at least the sign, on average, when 1937 number is positive, is going up with respect to its average, then 1938 is going down with respect to its own average. Or if I begin in 1940, on average, beginning in 1940, all numbers one lag away from 1940, all numbers one lag away from 1941, all numbers one lag away from 1942, they are all going below their averages when the beginning numbers are going above their averages. So what I'm trying to say is we are not done with the definition. So that's what I want to finalize tonight, okay? Everybody, that's what I want to try to finalize. Because what we have just done is identify the autocovariance at lag 0, autocovariance at lag 1, autocovariance at lag 2, and also therefore autocorrelation at lag 1, autocorrelation at lag 2, autocorrelation at lag 3. So what are we saying? We have said that if you begin in 1937 and create a series, 1937, 1938, 1939, and create the series of returns. That's our original column. And then you create another series that each number in the new series is exactly one number removed from the previous original series. That is the returns at lag 1. The relationship between those two numbers is what we call autocorrelation, this number. All right. You may not be following me now, that's okay. But let me do it so that you see what I mean. All right, so let's go back.
That was a good explanation, Professor.
Okay, thank you. Thank you so much. You guys, you make me feel good. Especially on a crappy day like this. So let me, all right. So let's go. I want to go and do something. So just bear with me, okay? That's okay. I'm allowed to slow this down. Let me insert rows. Okay, in case I have other things below. Now, everybody, please follow me now. So can anybody tell me this 1947? What lag is it away from 1937?
10 lags away.
It's lag 10. So what am I doing now, everybody? If I pick up this number and this number, what am I? I'm sorry. I'm doing this. So I pick up from 1947 to the end. Okay, and I copy it, and I want to scroll down, and I paste it here. What series have I just created? I've created
XT plus 10.
X
Lag
T
10.
plus 10. Okay, awesome, thank you. Now, everybody pay attention to what I want to do, okay? I'm loving this. All right, so now I want to go back here. Sorry, I have some hang-ups. My title always has to be aligned with my numbers. It messes me up if they're not aligned. So now let me go and copy all of this. And I copy. Okay, everybody just keep with me, please. I put it here. I paste it here. I'm just going to do maybe two of them. And I paste here. And I go here. I take this. I paste here. Oh my God, I messed this up. Okay. All right, let me do it again. Let me copy from here. You see how slowly I do things? Because I feel pressure from you all in my class, I'm actually doing it 10 times faster than when I do it myself. Because when I do it myself, I have my peanuts and my cashew and my whatever. All right. Hey, is Ian here, Mr. Murphy? Okay, good. Good. I'm just checking up on you, my buddy. Okay, I don't see him yet. Control C and Control V. Okay, thank you. Control copy and Control paste. All right. Okay.
Professor?
Now,
Professor? Also, if you want to select all the row until where you have information,
yes.
you just have to keep selected Shift and Control and down arrow, the down arrow key, and they all select all together until you have data. So you don't have to scroll down and scroll down until.
Okay. So it's what? Shift, Control.
Shift, Control, and down arrow.
Okay, good.
Thank you, bro. I was trying to figure that out last night.
Say that again. You were trying to figure it out last night?
I was trying to figure that out last night. I couldn't do it. I kept like scrolling down. It was so annoying.
Believe me, I know these things, but sometimes because you guys, you need to see my desktop and my Excel sheets. They are so complicated that sometimes I forget what numbers I have in the so sometimes I do make mistakes. Okay, but thank you for telling me that.
I think it's the caches, Professor. They play some sort of trick on you.
It's a caches. And by the way, before I worked on this, I worked on a bigger one. So that's what I do. That's the only thing that keeps me sane, and a glass of good stuff here next to me. Okay, so what have I done now? This is this is xt plus, this is lag 0, right? So this is lag 0. Sorry, this is lag 0. Okay. Now, let's create lag 1. So I go here, and I select up to here. Everybody bear with me now, okay? So I copy this and I put it here. And I paste it. All right. What have I just created? XT what?
11.
XT plus 11. Correct. Okay. Awesome. And okay. And then let me come in here and I go here and I take this. Okay. Sorry, you know, because sometimes when we write all these fancy notations in time series, it is sometimes difficult to visualize. That's why I'm trying to do this very slowly so that as much as possible, if you're following me, as much as possible, you can visualize what I'm doing, okay? So this is what? X, anybody tell me? T plus
12.
12. Awesome. You guys are fantastic. Okay.
Professor,
Yes, sir.
why didn't you put T plus 12 under the column lag 2?
Yeah, I'm just messing around. So this is lag 2. Is that what you mean?
That's actually lag 0.
This is lag 0. This is lag 0. T plus 10, T plus 10 is the same time period. I know that. Are you calling me a dummy? Okay. Okay.
I think where my misunderstanding is, where I think Danny is thinking the same thing, is that I guess a lag is considered those two columns, not just 10, 11, or 12. I'm not sure if he's feeling the same way, but like.
Say that again. Say that again.
One lag is considered those two columns together. They're associated. So I think he was thinking that XT plus 10 in the lag 2 group was considered lag 0, but it's actually those two columns together are lag 2.
Yes.
I'm not sure if I'm explaining that correctly, but.
No. Is that Lily?
Yes.
Yes, that's fine. That's correct. So let me explain this, okay?
No, I understand now.
Yeah, no. That's I'm not talking about. I'm not talking about you and Lily, Danny. I just want to review something that comes from statistics, okay? And this is for everybody because in time series, you also have to remember a little bit what you did in statistics and Echo 4000. We have a column of numbers. For example, the return to IBM from 1937 to 2020. We have that long column. That's a variable return. Is that right? So you can call it R for return. So we have a return to IBM from 1937 to year 2020. We have many, many numbers in there. That whole column is called a variable. But a specific number there is an observation. Maybe the return in the year 1940, 12%. That's an observation of the variable return. What I'm working on now is we are working on variables, columns. So when I say return at lag 1, I mean go down every year and take returns 1 year removed from each year. That's what we're doing. Are you with me? So when we say XT and XT plus 1, it means every number removed by one time period from the original series of numbers. So so when I say correlation, autocorrelation, I'm talking about autocorrelation between columns, where one column is the original set of numbers, and the other column is each number one time period removed from the original column is another column. Okay, now everybody pay attention to this very carefully, what I'm going to say in the next few minutes. All right. So this is lag 1. This is lag 2 from the original series, okay? Up here, we already did lag 0, lag 1, lag 2. Is that correct? And so this is the autocorrelation of all the numbers one time period removed. This one. And this is the autocorrelation according to my calculation for all numbers, 2 time periods removed from the original set of numbers. Let me pause here and ask, does everybody understand this?
Yep.
Okay.
Yes.
Okay. So can you explain this one? Can you explain these 2 columns now? These 2. Anybody explain that to me? Now, I have now started in 1947. Remember, xt plus 10 is 1947. Is that correct?
Yes.
Okay.
Yes.
How did I choose this? I just chose this totally arbitrarily. I could have chosen 1938 or 1962 to begin with. I could have chosen that. Everybody with me so far?
Yeah.
Okay.
Yeah.
All right. So what do you think I should do now? I should go here and calculate the autocovariance between xt plus 10 and xt plus 10. That is 0 lag. Is that correct?
Yes.
Yes.
And then when I finish, I should calculate the autocorrelation between xt plus 10 and xt plus 10. Is that correct?
That's the one.
If I
Yes.
if I calculate the autocorrelation between these 2 columns, what number will I get?
1. 1.
1
Which one, plus or minus? All you
plus
guys,
1.
you have just always tell me the sign for correlation. Okay, so it is
Plus 1.
I will get plus 1. Is that correct?
Yeah.
Yes.
Okay, so if I get plus 1, are we consistent or what? Are we consistent with this one?
Yes.
Yes, but those are 2 beginning points. I started this one. I started in 1937. Is that correct? Last Tuesday. And for this
37.
one, where did I begin?
47.
47. So these 2 are the same, even though I started in different points. Is that correct?
Yes.
Yeah.
So far, everybody understands that if I begin in 1937 and I create another column, lag 0 from 1937, which is exactly 1937, if I calculate the autocovariance between the 2, I must always get 1 plus 1, correct?
Mhm.
What if I began in 1938 and I create one column for beginning 1938 to 2007, another column beginning in the same 1938 to 2007. If I calculate the autocorrelation, what must be the number be?
It will always
Always
be
1.
1.
Plus 1.
Always 1.
Okay, I'm going to drive you all crazy. What if I started in year 1999 and I began in 1999 up to 2007? It's a shorter series now, and I do the same, and I calculate the autocorrelation beginning 1999 and 1999. What must the number be?
Plus
Plus
1.
1.
You see, I can continue and drive you all crazy. Okay, now,
But
so
what were you saying about the covariance?
I'm not talking about, forget the covariance. Let's talk about correlation now, okay?
Were you saying it's the same though? Like, was it the still? Because I heard someone. I missed that point.
No, the covariance does not have to be the same,
If it's the same point, okay.
okay? But the correlation has to be the same, right? Plus 1. right? Because even though I'm beginning at different points, 1937 and 1947 here, when I calculate the autocovariance and then I calculate the autocorrelation, then it has to be the same. Is that right?
That's right.
Okay, all right. Now, can somebody try this and calculate the autocovariance for lag 0 beginning in 1947? Did anybody do it?
I'll do it right now.
Okay, keep working on it, and when you finish, let me know. Okay. Good. So because this is the same, we already know that for beginning in 1937, the covariance is 406.904. Yes, everybody? That's what all of you got if you did it, this exercise between Tuesday and today. Okay. When Danny finishes, Danny is going to give us that number, okay? And then we shall check. Now, everybody, Danny, how close are you?
I was taking notes. I forgot. I didn't even know what you were referring to.
Okay.
307 is the covariance.
How much?
307 of
307.
xt plus 10 with xt plus 10.
So it's 30. So the covariance is 307. So let me just write
0.38.
307.38. Okay.
Wait, why did I get a different number? I got 305.068.
Okay. Let me go with 307.38. You could be right. One of you could be right. Okay. But let's go with the first number I got. That's okay. All right.
Yeah, I got what Alec got.
You got 307?
307.38.
Okay. Now I'm going to give you all not more than 2 minutes. Okay.
Maybe you did not the population one.
Yeah, do the population. Who did the population?
I think I did the
I did the population.
Okay, you did the population what?
Yeah.
Variance.
Covariance P.
Okay, but don't forget, always go to data analysis. Use the data analysis, okay? Because the data analysis is always guaranteed to be the population, at least in my Excel.
Yeah,
you guys.
I was just missing one of the cells. I did it.
Okay, so what is it?
307.378. Yeah.
Okay, good. All right, while I was waiting, I reached out for my cashew, but I'm not going to eat it. I'm in class. Okay, now, all right. I'm sorry to be unfair to everybody, but can a group of you calculate the same beginning in 1947 here for lag 1, and can a group of you do the same for lag 2? So not everybody. Some people do lag 1, others do lag 2. Okay. Can somebody tell me who wants to volunteer to do lag 1?
I can do lag 1.
Okay, Lily,
I can do lag 2 if you want.
Okay, do lag 2. So Lily, you're doing lag 1. Who, Danny or Joseph, or who just talked now?
It was me, Alec.
Alec. So Alec, go ahead and do lag 2. So Lily is doing lag. Yeah.
Okay, never mind. Yeah.
So
okay.
Lily is doing lag 1. Alec is doing lag 2, and the rest of you can support Lily or you can support Alec. Okay, and then let's confirm the numbers. It's already almost 7, so I need somebody to finish quickly. And so somebody just give me. Okay, from Joseph Joe, you say your variance P is 306.26. So this number is wrong. 307 is wrong, you're saying? Okay, Joseph Joe, I'll come back to this. Somebody verify this number again, the variance for portfolio, not portfolio, the variance for population, variance P. All right, somebody check on this number at lag 0. Anybody finish lag 1?
I did lag 2.
Lag 2, give me the number, buddy. Lag
okay,
2?
Lily, go first.
Okay, Lily,
she did lag 1.
Okay, Lily, give me lag 1.
So do you want covariance or do you want the correlation?
Let's do covariance. Let's do covariance for autocovariance.
Covariance, I have
autocovariance.
305.
Autocovariance.
Covariance is, you got autocovariance, apologies,
Okay,
is
it's what?
305.07.
305.07. Awesome. You're the best. Okay, thank you. 305.07. Fantastic. Okay. Somebody verify that, even if it's wrong, but tell me if you verified it. Okay. How about like 2? Alec?
I got a negative number.
That's okay.
Negative 52.72.
52.72. Okay. Somebody verify it for me. So I'm going to make this bold and red. And I'm going to make this
Wait, I'm sorry, can you scroll down for 1 second? I just want to see something.
bold. You want me to scroll down?
Scroll down to the bottom of lag 1. I just want to see because I didn't get the same number, so I want to see what I did wrong.
You want me to scroll down to this one? Okay, so I'm scrolling down here.
Yeah, I didn't get the same number, but I'll recalculate.
It's okay, just recalculate it. I just want to make a point before the class ends, okay, everybody? Okay, did anybody verify? Okay, everybody please listen carefully. I'm just going to assume that all these numbers are correct, okay? Can you look at the definition for weak stationarity again and tell me the third condition? Everybody?
Professor, can you go over the, but you didn't do it yet. Never mind.
Okay, I didn't do the calculation. I'm just assuming that whoever did it correctly, but let's just assume they are correct, okay?
Yeah.
I
I
took,
don't know why I'm not getting it right. I
Professor-
gotta look at 2 of them.
It's okay, we can figure it out at home, but for now,
Yeah,
just
the third requirement is that all the autocovariance function is constant between successive observations.
Okay.
That's
Everybody
the third
listen.
requirement.
Thank you, Danny. That's correct. So everybody listen to me carefully because I want to explain this. This number is autocovariance at lag 0, yes?
Yes.
What is this number? Autocovariance at lag
Lag
0,
0.
but beginning at a different point. Is that correct?
Yes.
Okay. These two numbers are different. Obviously, if we assume this number is correct, then these two numbers are different. Is that correct?
Mm-hmm.
Okay. What is this number?
Negative 4.
Autocovariance at lag
1.
1. What is this number? Autocovariance at lag
1.
1, but beginning at a different time period. Is that right? Yes, they are different. They are different.
so I have a quick question. Which one am I taking? So I may have been taking it from the wrong column, right? So for your example, do we take negative 4.8 or do we take 412? And what is the difference?
No, this is the variance of xt plus 1 and xt plus 1. This is the variance. You remember along the diagonal, these are the variances.
Okay. So then, okay.
Okay. So what I'm trying to say is that this number here is different from this number. Why are they different? Because they are removed from, at this point, I began in 1937. Is that correct?
Yes.
And I created another column 1 time period away, but beginning in 1937. Is that correct? At this point, I began in 1947. And I created another column beginning 1 time period away, beginning in 1947. Is that correct? You all saw me do this, yes?
Yes.
Okay. Why the difference? The difference is because we have shifted the whole series from here to here. We have shifted it 10 time periods into the future. Is that correct? Oh, you guys,
Yes.
you have to.
Yes.
Okay, good. Excellent. Okay. So you're saying this 52 is wrong?
No, my 305 is actually, it's negative 54.98. I was taking the wrong number from
Okay.
from the
this
data
is,
analysis.
okay,
I was
so
misunderstanding.
it's all right. So this is
the
this
graph
is
that I did. I think I did it wrong.
this is negative what?
54.98.
54.98.
Negative though.
Yes, negative, yes. Okay, thank you for clarifying that. Look, the only difference between this number and this number is what? Is because we moved 10 years into the future and started taking the distribution. Is that right?
Yes.
Okay.
Yeah.
And the difference between this number and this number, these are all lag 2, and these are all lag 2, but the starting point is 10 years different. Is that right?
Yeah.
Okay. Because everybody pay attention, please stop typing. Because this number and this number is different. This number and this number, they are different. This number and this number are different. And if you do it for all the 12 as well as forever, keep doing it, and they're all different, then our process, the return to IBM is not stationary. You understand?
Repeat that last statement about not stationary.
Okay. For the returns to IBM,
Right.
the population returns to IBM, for that population return to be stationary, is that right?
Mm-hmm.
This number should be equal to this number. This number should be equal to this number. This number should be equal to this number, because they are all lag 1 removed from the original number, no matter where we started. That is the definition of stationarity. It means that if I begin today and I look at the distribution of return for 50 years in the past, and I begin and I calculate the mean, I calculate the variance, and I calculate all the autocorrelate covariances and autocovariances 1 period removed. And then 5 years from now, I look back and I take 50 years and I calculate the mean, the variance, and the autocovariance, from 2 time periods removed. And I lag 2, lag 3, lag 4, lag 5. And if the autocovariances are the same, no matter where I start, then that distribution is stationary. You see how deep that definition is?
So it's not.
Wait. So do you guys understand how deep that distribution is? So because these numbers are not the same. These numbers are not the same. This at lag 2 is not the same. At lag 1 is not the same. At lag 0 is not the same. At lag 0, even though we shifted 10 years apart, they are not the same. So this and if you continue and look at all the lags of interest, they are not the same. So the time series is not stationary.
So we have to use 2 different samples of like time in order to figure that out.
What exactly do you mean by that?
Like you have to use, like you used 1 like on the top, and then we tried it again like 10 lags later. Like 10.
Yes. And then if you go and try, if you begin in 1957, okay,
right,
and you create from 1957 will be lag 0, and you do another 1957 lag 0, and you calculate the autocovariance, which is the variance, and then you do from 1957 and you create it, and then you do another lag 1 from beginning 1957, you create another column, just like we've done here. If all those numbers are different, if all those numbers are the same, no matter where you started from, if the lag 0 number, the lag 1 number, the lag 2 number is the same, no matter where you began to do your distribution, your series, then that time series has a stationary distribution.
Got it.
So you see how tough, you see how tough or how very stringent the requirement is for stationarity. You understand that now, right?
Yeah.
Okay. I'm going to stop recording.
The recording has stopped.
Okay. So this third condition for stationarity is very, very stringent. Everybody with me?
Yep.
Okay. Next week, I'll continue from here because next week, I will now begin to describe for us the models of time series that are of great interest. Okay, everybody? So from next week, I'll begin to discuss for all of us, I'll begin to introduce to all of us the models that are of interest to us. Why is that important? Because if I ask you maybe 2 or 3 weeks from now, I ask you to go and get the time series of return for the past 15 years for Facebook. And I ask you, what kind of time series is that? Okay, you have to be able to tell me that that time series is like this. Because I'm going to next week begin to introduce you to different kinds of models. Everybody, let me say one last thing and then you can leave, okay? Suppose I ask you guys, there's a new student coming to this class. Can you guys tell me whether that new student is Chinese? Well, first of all, that person will come in, but suppose that person is me. I'm Joseph. That new student is Joseph Onochi, and you look at me. Will you say I'm Chinese? Of course not, because I'm, the way I talk. No, citizenship doesn't matter. Of course, I can go to China and become a Chinese citizen, even though I'm from Nigeria. But let's remove that. But just looking at the feature of me, do I look like Chinese? You say no. I say why? Because you say if I'm Chinese, then maybe my skin will be a little bit lighter than now, and maybe the way I speak and something. Because there's a difference between in physical nature and maybe the way we talk from Chinese and Nigerian or Chinese and Mexican. Why? Because each of these groups we have distinguishing characteristics. So if I ask you to go somewhere and choose somebody, and that person needs to be an American from New York, the first thing you ask me, what does an American from New York look like? And I'll give you all the characteristics. And then with those characteristics, you go looking in California, or you go looking in Mexico, or you go looking in Beijing for an American with those characteristics. The same way, beginning next week, next Tuesday, I'm going to begin to introduce us to popular time series, different types of time series. The most basic type of time series is called a white noise. And then another popular one is called an autoregressive time series. Another one is called a moving average. Another one is called an autoregressive moving average. And then another series of types of time series are called ARIMA, autoregressive integrated moving average. So in other words, beginning next Tuesday, you and I are going to begin to learn about the characteristics of different popular time series models. So that if I ask you 3 weeks from now, hey, Sophia, Dimitri, Sylvia, 3 of you, I put you in the same team, go to Yahoo and download Facebook and then tell me whether Facebook is white noise or AR or MA or ARMA or ARIMA. Before you go download Facebook, you and I will have studied the specific characteristics of white noise, characteristics of autoregressive, characteristics of MA, and so on and so forth. Are you following me now? Yeah?
Yeah.
Okay. So beginning Tuesday, I'm going to begin to introduce to what is a white noise, and then we'll study it, and then what is an autoregressive AR, and then what is an MA, and what is an ARMA. And the trick is we're going to be studying the characteristics of their autocorrelation functions and their mean and variances. So there are many ways we study the characteristics of the different kinds of time series models. Okay, everybody, bye-bye.
Professor,
Yeah?
I do have a question, but regarding midterm, do you want to discuss it right now or maybe next class?